qualified electrician is an individual who possesses the knowledge, skills, and experience to safely perform electrical work in accordance with established codes and standards. They must demonstrate competence in electrical theory and principles, electrical code interpretation, electrical installation, maintenance and repair, troubleshooting and diagnostics, and safety procedures and protocols. To become a qualified electrician, individuals may meet one or more of the following criteria. Firstly, education and training can be achieved through the completion of an accredited electrical apprenticeship program or an associate degree in electrical technology. Secondly, experience can be gained through years of supervised electrical work experience under the guidance of a qualified electrician. Thirdly, licensure or certification can be obtained from a recognized regulatory body. This includes a licensed electrician granted by a state or local government agency, and journeyman or master electrician certification issued by the National Electrical Contractors Association known as NECA, or the International Association of Electrical Inspectors, abbreviated as IE. Now let's discuss the difference between a qualified and certified electrician. A qualified electrician refers to an individual who meets the minimum requirements to perform electrical work safely and competently. They may have gained their qualifications through education, training, or experience, but they are not necessarily certified. A certified electrician refers to an individual who has passed a recognized certification exam demonstrating advanced knowledge and competency in a specific electrical field or specialty. Certification is typically voluntary and requires ongoing professional development. Employing qualified electricians ensures safety because they adhere to electrical codes and standards, minimizing the risk of electrical hazards. Reliability is assured because they possess the skills and knowledge to accurately diagnose and repair electrical issues. Compliance is achieved because they ensure that electrical installations meet regulatory requirements. Efficiency is increased because they optimize electrical systems for optimal performance and energy efficiency. Electrical theory encompasses fundamental concepts that govern the behavior of electricity. These include Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding series and parallel circuits is crucial. In a series circuit, components are connected end to end, so the same current flows through each component. The total resistance is the sum of individual resistances. In a parallel circuit, components are connected side by side, so the voltage across each component is the same. The total resistance is calculated using the reciprocal of the sum of the reciprocals of individual resistances. Power calculations are also essential. Power, measured in watts, is the rate at which energy is transferred. It can be calculated using the formula power equals voltage times current. Understanding alternating current, or AC, and direct current, or DC, is important. In direct current, electrons flow in one direction. In alternating current, the direction of electron flow reverses periodically. Transformers are used to step up or step down voltage levels in AC circuits. Electrical code interpretation involves understanding and applying the National Electrical Code, or NEC, which provides standards for safe electrical installations. This includes understanding wiring methods such as conduit, cable, and raceway systems. Conduit is a rigid or flexible tube used to protect and route electrical wiring. Cable consists of two or more conductors insulated from each other and enclosed in a protective sheath. Raceway is an enclosed channel designed to hold and protect electrical wires and cables. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Grounding and bonding are critical for safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device. Bonding connects metal parts together to create a low impedance path for fault current. Understanding the NEC tables is necessary for determining conductor ampacity, which is the maximum current a conductor can carry without exceeding its temperature rating. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 2000 volts, based on their insulation type and ambient temperature. Electrical installation, maintenance, and repair involve the practical skills needed to install, maintain, and repair electrical systems. This includes wire termination techniques, such as using wire connectors and terminal blocks. Wire connectors are used to join two or more wires together. Terminal blocks provide a convenient way to connect and disconnect wires. Lighting installation involves installing various types of lighting fixtures, such as incandescent, fluorescent, and LED lights. Incandescent lights produce light by heating a filament until it glows. Fluorescent lights produce light by passing an electric current through a gas-filled tube. LED lights produce light by using a semiconductor diode. Motor control involves installing and maintaining motor starters, variable frequency drives, and other motor control devices. Motor starters are used to safely start and stop electric motors. Variable frequency drives are used to control the speed of electric motors. Troubleshooting and diagnostics involve identifying and resolving electrical problems. This includes using testing equipment, such as multimeters, clamp meters, and circuit tracers. Multimeters are used to measure voltage, current, and resistance. Clamp meters are used to measure current without disconnecting the circuit. Circuit tracers are used to locate wires and identify circuit breakers. Common electrical problems include open circuits, short circuits, and ground faults. An open circuit occurs when the current path is broken. A short circuit occurs when current flows through an unintended path with low resistance. A ground fault occurs when current flows from a live conductor to ground. Safety procedures and protocols are essential for preventing electrical accidents. This includes lockout-tagout procedures, which are used to de-energize electrical equipment before working on it. Personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits, should be worn when working on electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Safe work practices include maintaining a safe distance from energized equipment, using insulated tools, and avoiding wet conditions. Experience is a critical component in becoming a qualified electrician. Many jurisdictions require a certain number of hours of supervised on-the-job training. This hands-on experience allows aspiring electricians to apply theoretical knowledge in real-world scenarios. Under the guidance of experienced professionals, apprentices learn to install wiring, troubleshoot problems, and adhere to safety protocols. The duration of required experience varies depending on the specific location and licensing requirements. It is crucial to document all work experience meticulously, as this record will be necessary when applying for licensure or certification. Continued education and training are vital for electricians to stay up to date with the latest technologies, codes, and safety practices. The electrical field is constantly evolving, with new materials, methods, and regulations being introduced regularly. Electricians can pursue continuing education through various avenues such as workshops, seminars, online courses, and manufacturer training programs. These opportunities allow them to enhance their skills, expand their knowledge, and maintain their professional competence. Furthermore, staying informed about changes to the NEC and local electrical codes is essential for ensuring compliance and safety. Many jurisdictions require electricians to complete a certain number of continuing education hours to renew their licenses or certifications. A license is a mandatory requirement for electricians in many areas. It is a legal authorization granted by a government agency permitting individuals to perform electrical work within a specific jurisdiction. Licensing ensures that electricians have met certain minimum qualifications and are competent to perform their duties safely and responsibly. The requirements for obtaining an electrician's license vary depending on the location. Typically, candidates must complete an apprenticeship program, pass a written examination, and demonstrate a certain amount of work experience. The examination usually covers topics such as electrical theory, code compliance, and safety practices. Once licensed, electricians are required to adhere to ethical standards and follow all applicable laws and regulations. Failure to do so can result in disciplinary action, including suspension or revocation of the license. A certification, on the other hand, is often voluntary, but it can significantly enhance an electrician's credentials and career prospects. Certifications are typically offered by professional organizations such as NECA and IE, or by industry-specific training providers. These certifications demonstrate that an electrician has achieved a certain level of expertise in a specific area of electrical work. To obtain a certification, candidates usually need to meet certain eligibility requirements, complete a training program, and pass a certification exam. The exam may be written, practical, or a combination of both. Maintaining a certification often requires ongoing professional development and periodic renewal. Some common electrical certifications include those related to specific types of equipment, such as solar photovoltaic systems, or specific areas of expertise, such as electrical inspection. Electrical safety is paramount. Electricians must be well versed in safety procedures and protocols to protect themselves and others from electrical hazards. This includes using appropriate personal protective equipment, such as insulated gloves, safety glasses, and arc flash suits. Lockout-tagout procedures are essential for de-energizing electrical equipment before working on it. These procedures involve disconnecting the power supply and placing a lock and tag on the disconnect switch to prevent accidental re-energization. Electricians must also be aware of the dangers of arc flash and take precautions to minimize the risk of exposure. This may involve using specialized tools and equipment such as arc flash-rated clothing and face shields. Regular safety training is crucial for keeping electricians up to date on the latest safety practices and procedures. The importance of qualified electricians cannot be overstated. Their expertise ensures that electrical systems are installed, maintained, and repaired safely and reliably. By adhering to electrical codes and standards, they minimize the risk of electrical hazards such as fires, shocks, and explosions. They also ensure that electrical systems operate efficiently, reducing energy consumption and saving money. In addition, qualified electricians play a vital role in ensuring compliance with regulatory requirements. This helps to protect consumers and businesses from potential legal and financial liabilities. When hiring an electrician, it is essential to verify their qualifications and credentials. Check their license status with the appropriate licensing agency and ask for references from previous clients. Make sure they have the necessary experience and expertise for the specific type of electrical work you need done. Don't hesitate to ask questions about their safety practices and insurance coverage. Investing in a qualified electrician is an investment in safety, reliability, and peace of mind. The work of electricians directly impacts the safety and well-being of individuals and communities. From powering homes and businesses to supporting critical infrastructure, electricity is an essential part of modern life. Electricians play a crucial role in ensuring that this power is delivered safely and efficiently. Their skills and knowledge are vital for maintaining the reliability of electrical systems and preventing electrical accidents. By upholding high standards of professionalism and safety, electricians contribute to a safer and more sustainable future.